Hello and welcome to Applied Pharmacology, DEH 117. One of your writing assignments for this class is going to be an article critique. This is a bit different than what is expected of you when writing an APA-styled research paper. For an article critique, you are going to demonstrate your understanding of what exactly a primary research study is reporting. This PowerPoint will teach you the basics about research so that you can identify the different parts, and maybe it'll help you to better understand what you are reading. So the first part of your article critique, you will have it titled, and you'll find a sample paper inside the folder where you found this video link. So take a look at that. If you can stop this video at any time and just take a look at the papers that I have uploaded alongside this. They're there to help you. So the first section of the paper, you're going to just introduce the authors. So it's an introduction, which includes the author's introduction and abstract. You'll answer the questions. If potential conflicts of interest exist, did they appear to influence the study's objective, methods, or conclusion? What is the funding source? Was an appropriate scientific background and rationale provided? Is the stated objective or hypothesis consistent with the research question that needed to be addressed? What are the variables? You have the independent, dependent, and extraneous. The journal title, date, publisher, and if it's peer-reviewed. Of course it will be. And what are the author's qualifications? Does the abstract contain the necessary elements such as the purpose, sample, methods, results, and conclusion? In the methods section, this will include the design, your patients and subjects, and outcome measures. In the designs, we're going to get a little bit more detailed here. There are 8 common study designs. We have reviews or meta-analysis, correlational or ecological studies, case studies, cross-sectional studies, case control studies, cohort studies, experimental studies, and qualitative studies. So we're going to begin with systematic reviews. A systematic review is a comprehensive survey of a topic that takes great care to find all relevant studies of the highest level of evidence, published and unpublished, that assess each study, synthesize the findings from individual studies in an unbiased, explicit, and reproducible way, and present a balanced and impartial summary of the findings with due consideration of any flaws in the evidence. In this way, it can be used for the evolution of either existing or new technologies and practices. So if you look at the study diagram here, this kind of gives you a visual of what it just said. So it takes from many different studies. It's a rigorous analysis of each of them, and then it produces a systematic review. So basically, a systematic review is much more rigorous than a traditional literature review and attempts to reduce the influence of bias. Then we have the meta-analysis. The meta-analysis is a systematic, objective way to combine data from many studies, usually from randomized, controlled clinical trials, and arrive at a pooled estimate of treatment effectiveness and statistical significance. So a meta-analysis can also combine data from case control and cohort studies. The advantage to merging these data is that it increases sample size and allows for analysis that would not otherwise be possible. They should not be confused with reviews of the literature or systematic reviews. So 2 problems exist with the meta-analysis, and that is that publication bias. Studies showing that either no effect or little effect are often not published and just filed away. And the quality of the design of the studies from which data is pooled. This can lead to misleading results when all data on the subject from published literature are summarized. Okay, so now we're at correlational or ecological studies. Correlational studies use population level data to examine the relationship between exposure rates and disease rates. Take a look at the graphs to the right. Here we have where the axis X and Y have met, and there's a little X there. And you can see that it has formed a positive slope, so it's going upward. And that's a positive correlation, and it shows that one variable X increases the other as the other increases. So in the negative correlation, you can see that's a downward slope. This shows that one variable increases and the other decreases. And then of course there's no correlation, and that shows they're just scattered. It shows that there is no connection between the two variables. So important to know, with correlational research you do not show causality, A causes B. But you can show relationship, which is A is associated with B. This is a very important distinction. Correlational research design can be used to determine to what degree two things are related and to describe the nature and strength of the relationship. So case series, these consist either of collections of reports on the treatment of individual patients with the same condition or of reports on a single patient. So if you see the diagram, you have the patients going to the chart notes, and then it gets combined into a journal article. That's a case series. So case series or reports are used to illustrate an aspect of a condition, the treatments, or the adverse reaction to treatment. So here's an example. You have a patient that has a condition that you are unfamiliar with. You would search for case reports that could help you decide on a direction of treatment or to assist on a diagnosis. So case series or reports have no control group, so there's not one to compare outcomes. So they have no statistical validity. The benefits of case series or reports is that they are easy to understand and can be written up in a very short period of time. Cross-sectional. A cross-sectional survey provides a snapshot of the health status of a population at one point in time. Cross-sectional surveys, sometimes called prevalence studies, are among the most popular study approaches in the health sciences because they allow for the relatively rapid collection of new data. Here you can see different groups compared at one time. You can see the diagram. So some questions can take a long time to answer, such as when do kids begin to use tobaccos, or when do they begin to get caries? One way to answer these questions is to follow a group of individuals over a long time, which would be considered a longitudinal study. This approach is expensive, and there are many problems with following over time as people move. Another way of answering this type of question is to conduct a cross-sectional study. This is where you look at various ages simultaneously, such as how many in each grade at school use tobacco, to see when tobacco use begins. Case control studies. A case control study compares the exposure histories of people with and without a particular disease in order to identify likely risk factors for the disease. So you can see the diagram to the right. Case control studies are generally designed to estimate the odds using an odds ratio of developing the study condition or disease. They can determine if there is an associational relationship between condition and risk factor. So an example of a case control study, a study in which colon cancer patients are asked what kinds of food they have eaten in the past, and the answers are compared with a selected control group. Case control studies are less reliable than either randomized controlled trials or cohort studies. A major drawback to case control studies is that one cannot directly obtain absolute risk, such as incidence of a bad outcome. The advantages of case control studies are that they can be done quickly and are very efficient for conditions or diseases with rare outcomes. So cohort studies. A cohort study follows participants through time to calculate the rate at which new disease occurs and to identify risk factors for the disease. So take a look at the diagrams over to the right. You can see the group of interest, the smokers, and you're going to have a comparison group, which are non-smokers. You follow them over time, and then you'll compare the outcomes. So was the risk of developing cancer a lot lower for those people that did not smoke, or was it a lot higher for those that did smoke? So also called longitudinal studies. Cohort studies are also called longitudinal studies, and they involve a case-defined population who presently have a certain exposure and or receive a particular treatment that are followed over time and compared with another group who are not affected by the exposure under investigation. Cohort studies may be either prospective, which means exposure factors are identified at the beginning of a study and a defined population is followed into the future, or historical or retrospective, which is past medical records for the defined population are used to identify exposure factors. So cohort studies, they're used to establish causation of a disease or to evaluate the outcome or impact of treatment when randomized controlled clinical trials are not possible. So, as you know, randomized controlled clinical trials are the golden standard for the validity of research. So, example, one of the more well-known samples of a cohort study is a Framingham heart study, which followed generations of residents of Framingham, Massachusetts. Cohort studies are not as reliable as randomized controlled studies, since the two groups may differ in ways other than the variable under study. Other problems with cohort studies are that they require a large sample size. They're inefficient for rare outcomes and can take a long period of time. So, experimental studies. An experimental study assigns participants to intervention and control groups in order to examine whether an intervention causes an intended outcome. So, you can see we've seen experiments done and as far back as high school, but this gives a little diagram of what it takes. You have your patients, there's a random assignment, you have the treatment groups and the control group, and then you follow up with each, and then you compare the results. So this design is considered the gold standard when comparing interventions. However, not all questions can be answered with this approach. A randomized controlled study consists of two or more groups. One receives the experimental treatment and the other is the control. Participants are randomly assigned to the group. There are certain types of questions on which randomized controlled studies cannot be done for ethical reasons. For instance, if patients were asked to undertake harmful experiences like smoking, or denied any treatment beyond a placebo when there are known effective treatments. So touch on a little bit for the blinding and masking. Blinding, sometimes called masking, occurs when participants in an experimental study and perhaps some research team members do not know whether a participant is in the active intervention group or the control group. In a single blind study, participants are unaware of their exposure status. In a double blind study, neither the participants nor the persons assessing the participants' health status know which participants are in the active and control group. So, for example, studies of treatments that consist essentially of taking pills are very easy to do a double blind. The patient takes one of two pills of identical size, shape, and color, and neither the patient nor the physician needs to know which is which. In a double-blind study, that is the most rigorous clinical research design because in addition to randomization of subjects, which reduces the risk of bias, it can eliminate or minimize the placebo effect, which is a further challenge to the validity of a study. So, statistical significance. This is going to be really brief. You're going to see this actually discussed in the sample paper. If you have not taken statistics yet, you probably are not familiar with what this slide is about, but it'll at least guide you and it'll explain a little bit of why that was even placed in the paper. The p-value is the probability value. It's a statistical test that's used to decide whether the results observed are likely to reflect real differences between groups. So the null hypothesis, that's the little h with a small o or small zero, that the null hypothesis, if it means the means are not different, if p is less than 0.05, you'll reject the null hypothesis, and that will mean that the means are different. If probability is greater than or equal to 5% or 0.05, it fails to reject the null hypothesis. So the means are not different. It does get a little confusing, but that is what you're looking at. So if p is less than 0.05, there is statistically it's significant. So just keep that in mind. Okay, so qualitative studies. A qualitative study looks for the themes and meanings that emerge from the observation and evaluation of a situation or context. So qualitative studies is one of the biggest distinctions in approach. So it's easy to see the comparison summaries of differences in purpose, questions, methods, and outcomes, quantitative versus qualitative. So with quantitative, you've got the testing, the theory, establishing facts, and you show relationships between variables. With qualitative, which is what we're talking about, it's actually developing theory, exploring a topic, and developing a hypothesis. So a qualitative, it begins with a vague or general question or broad topic, and questions such as why do people choose tooth loss instead of restoration? What do people think of dental hygienists, and why do some people volunteer? So they're more open-ended questions. So quantitative, it begins with a specific hypothesis that addresses one issue. So daily fluoride use will reduce caries. Frequent periodontal maintenance will reduce periodontal disease. So that just gives you an idea. So that leads us to the levels of evidence, and it's based on validity. The highest is the systematic reviews and meta-analysis. Okay, that's the reviews of studies in literature, and it's been decided that these are the most reliable sources. But if it's too much information when you're trying to write a report, they're great to look at. They're actually one of the great things to begin looking at when trying to find articles to support your research. So when you're writing a research paper. So why? It's because you can look through the study, you can find some really interesting facts or something that was a really strong suggestion or a really strong point made in their review or their meta-analysis, and you can find in the bibliography where the actual primary resource. So that is what I really like using the systematic review and meta-analysis for. The second highest is the randomized controlled double-blind studies. There is single-blind studies. As a matter of fact, the paper that I will be giving you, or that is actually located in the file for your actual project to be done for your literature critique or the article critique, it is a single blind study. So, but it is a centralized, randomized, controlled study. It's interesting, but you'll see it in the folder if you want to take a look at it. The next one is the cohort study, then the case control studies, case series, case reports, ideas, editorials, opinions, animal research, and finally in vitro or test tube research. So since this is one of the questions in your rubric, in vitro study. In vitro study is just a study conducted in a setting other than an actual live situation. So an example would be irrigation is tested on tissue in an artificial environment. In vivo, that's a study conducted with real live subjects. An example is irrigation is tested on microorganisms in plaque on teeth of a live subject. Variables. Independent variable is the intervention. It's the variable being manipulated. It is known as the independent variable or the experimental variable. It is the causal factor capable of producing change in the dependent variable. So the dependent variable is the outcome. It's the variable that will be measured to see if the manipulation had any effect, and its value is affected by the presence, absence, or manipulation of the independent variable. So when doing research, the idea is to have a control group that is similar as possible to the test or experimental group. All variables should be the same for both groups, with the exception of the variable that is intentionally being manipulated or studied. So, definition. If you are, definition example, if you are studying the effects of a new toothpaste on caries, the variable being manipulated, the independent variable, is the type of toothpaste. Independent variable example, if you are studying the effects of a new toothpaste on caries, the variable being manipulated is the type of toothpaste. A dependent variable example, if you are studying the effects of a new toothpaste on caries, the amount of caries is the dependent variable. It depends on the toothpaste used. So control. The researchers attempt to control or eliminate interfering and irrelevant influences from the study. Extraneous variables, events that could potentially cause changes to the dependent variable. Their effects could be mistaken for those of the independent variable. And need to identify and control extraneous variables to ensure valid research. Extraneous variables threaten the validity of the study. So for an example, if you're comparing two different toothbrushes to see which is more effective in removing plaque, you might have interference if subjects are also using floss or mouth rinses or if they're taking antibiotics. So control of the extraneous variables allows the researcher to say that the results are due to manipulation of the variables and not to chance interference. If you have two similar groups, one will receive the manipulation and one will not. And in the end, there's a significant difference between the groups. You can be fairly sure that the difference is due to the manipulation. So the use of a control group is the easiest way to control for extraneous variables. You should be familiar with this: peer-reviewed or refereed journals. As always, use peer-reviewed or refereed journal to obtain articles that will support your research topic. You can verify if the publication is peer-reviewed by going to the journal's website and read what it has to say about their articles. The Journal of Dental Hygiene is peer-reviewed, and so is Dimensions of Dental Hygiene. RDH magazine, no, that is not considered a peer-reviewed magazine. So just be aware of that. Peer-reviewed or refereed journals means that the articles have been reviewed by peers. Before an article is published in a refereed journal such as the Journal of Dental Hygiene, the article is reviewed by several qualified dental hygienists to be sure the study is well written and the methods and conclusions are valid. So primary sources, I'm sure you've heard of this. The primary sources are the best sources to have to support your topic. So for a primary source, it's written by the individual or individuals who actually conducted the research. They are referred identified because they contain the following sections or subheadings: introduction, review of the literature, methods, materials, results, and discussion. Primary sources are considered superior when looking for evidence. Secondary sources is written by someone other than the researcher. Someone reads primary sources or paraphrases or rephrases. This is the great tip. Look in the bibliography of meta-analysis and review articles for peer-reviewed sources. So even if you happen to have an article that you found interesting, but it isn't from a peer-reviewed journal, go ahead and look in their bibliography. They may have something that is peer-reviewed that they used as an example to support their argument or their position. Okay, so finally, the article critique. I'm going to give you a brief explanation here about how I want it formatted. The final paper is going to be due June 21st. I would like to see that you're actually working on it, you're spending time, because it's really important that you understand research at this point in time. So any questions, you can come to my office, and my office hours are listed on the syllabus. The final article, again, is going to be due June 21st. It doesn't need to be more than 2 pages long. To get all the information, it's going to be at least 1.5 pages. So your paper is going to be in APA format without a running head. So you should follow the guidelines that you can find at Purdue OWL. If you don't have that website, you can go to the last slide with my references, and you can just click on it. There's a link right there. And there are several different YouTube videos. I just looked at them to make sure you guys wouldn't be stuck. Several different videos that will help you with the hanging indentation for the reference page, and along with a variety of formatting tutorials. So if you need any help with your APA format, if you can't make the time to come see me, please look it up on YouTube. The answers are there. Also, please watch the next video. I'm going to show you the sample paper and kind of go over it so that you can have an idea of what I want from you on your own article critique. Thank you.